Hello everyone, my name is Kuntal Chattopadhyay and today I am here to present a case study done to understand the impact of COVID-19 on energy consumption in a residential complex in Hyderabad, India. The presentation is structured into four significant parts, starting with the introduction where we will be presenting the background to the study, its aim, and will give an overview of the paper, followed by methodology where we will explain our approach to the paper. In the third section, insights to the study are provided, and finally, the paper is concluded in the last section. When the Indian government declared the first lockdown on 25th March 2020 to control the increasing number of COVID-19 cases, people were forced to stay at home and work from there. According to the reports, more than 80% of the workspaces were closed completely or partially worldwide. Globally, the energy demand reduced by 3.8% within the first 3 months of lockdown, although there was an increase in the energy demand for the residential buildings. Several studies have shown that there is an energy shift from commercial and industrial buildings to the residential buildings. The aim of this study is to quantify the impact of stay-at-home orders on the residential air conditioning and household electricity consumption for the Indian context. Further, the following hypotheses were made and tested. Working from home during weekdays would lead to an increase in energy consumption since occupants may cook lunch, use AC and other electrical devices during the day. The energy consumption during nighttime is expected to reduce due to the pre-cooling effect when the ACs are operated during daytime. There may be a delay in morning peak since people may wake up late as they don't need to commute due to the work from home. Further, the results were also checked to confirm whether these hypotheses are statistically significant or not. The data utilized for this study was gathered from a residential complex in Hyderabad. It is a city in the Telangana region located in southern India. The pandemic COVID-19 was unforeseen and unpredicted. Luckily, we were able to collect the AC energy and electricity consumption data for the non-COVID and COVID periods. The data is collected from a residential complex consisting of 380 homes. There is an entity in the complex which records electrical and cooling readings in 30 minutes intervals separately. The electricity data of these homes were collected using smart meters, stored dynamically at the local base and automatically retrieved every month. For each home, household electricity was measured for the entire home except AC energy. Since chilled water system was used to provide cooling to the building, it was not a part of household electricity consumption. The AC energy was measured separately in kilowatt-hour thermal, and the household electricity was measured in kilowatt-hour units. In this slide, we can see the picture of residential complex along with the typical floor plan of the building. The picture of the energy meter and the B2 meter is also shown below. The outdoor temperature for the Hyderabad region was collected from the website. It was observed that the average outdoor temperature for the year 2019 was more than that of 2020. To overcome this, days with similar average temperature range were selected. We segregated the daily average temperature in two sets, set low and set high. Set low for the medium temperature range, that is 31 to 33 degrees Celsius, and set high for high temperature range, that is 33 to 35 degrees Celsius. Same number of days in each set was taken, such that average temperature in both the years was similar. In the last step, the common homes which were occupied from 380 homes were taken for both the years to get more unbiased results. We can see the details of the filtration process in this slide. In the beginning, there were 30 days in the month of April in both the years. Further, weekdays were selected among the 30 days. From the above 22 days in each year, 7 days in 2019 and 6 days in 2020 were having similar temperature range. Similarly, 8 days in 2019 and 12 days in 2020 were having similar temperature range. Further, same number of days were selected from both the temperature ranges to avoid any kind of bias. If we look at the fifth and sixth column, we can see that the gap between temperature for both the years is getting reduced, and at the end we are having similar temperature range for both the sets. In this slide, the results for the set low is provided. The average per day per home AC energy consumption, number of operating hours, and household electricity consumption was calculated for both the years. It can be seen that the AC consumption has increased by 3.68% and the household electricity consumption has increased by 15% for the year 2020. Similarly, the average per day per home AC energy consumption, number of operating hours, and household electricity consumption was calculated for both the years for set high. The AC consumption has increased by 4.4% and the household electricity consumption has increased by 15% for the year 2020. The percentage increase in AC energy consumption for the set high is more as compared to set low because of higher temperature range, whereas we can see similar percentage increase in the case of household electricity consumption as it is independent of the temperature. In this slide we can see average per day per home AC consumption throughout the day for the set low. It can be observed that the AC energy consumption is more for 2019 from midnight till morning 6 am. After that, the AC consumption is more for 2020 till 9 pm. As per our study, the consumption during the day is increased by 22.23% for this temperature set. Further, similar kind of trends can be seen for the set high as well. The AC energy consumption is more for 2019 in the morning till 6 am. After that, the consumption is more for 2020 till 9 pm. The AC consumption for this set during the day is increased by 26%. AC energy consumption during the night time for the year 2019 is more than the year 2020 for both the sets. This can be expected due to the pre-cooling effect. We can see similar trends for set high as well. According to our study, on an average, the AC was operated 11 hours per day for the year 2020 and 10 hours per day for the year 2019. Nighttime operating hours was less in 2020 by 5.37% when compared to 2019 for set high. The peak demand during the daytime has also increased for both the sets. We can see similar trends for high as well. According to our study, on an average, the AC was operated 11 hours per day for the year 2020 and 10 hours per day for the year 2019. Nighttime operating hours was less in 2020 by 5.37% when compared to 2019 for set high. Further, the peak demand during the daytime has also increased for both the sets. The average per day per home household electricity consumption was also computed and plotted. The household electricity consumption for the year 2020 has increased by 15% for both the sets. Also, there is an increase in the peak consumption for the year 2020 when compared to 2019. Additionally, there is a shift in the peak during the night time. The increment in household electricity consumption is similar for both the sets, as there is no direct impact of temperature on the household electricity consumption. Also, the percentage increase in the household electricity consumption is significantly more during the day for the year 2020, whereas during the night time, household electricity consumption is similar for both the years. Furthermore, the household electricity consumption for the year 2019 was more during early morning between 4 am to 8 am. For the rest of the day, the electricity was consumed more for the year 2020. These results indicate that the people were using more electrical appliances such as monitors, laptops, TV, lights, cooking induction during the lockdown as people were staying at home. The significant test is performed to check whether the observed differences between assessment results occur because of sampling error or chance. For our study, paired t-test was used as the sample were taken from a single population. The test was conducted on the AC energy, number of hours AC was operated, and electricity data, as the data was operated from a same source, that is homes. The test was performed using 95% confidence interval. In this table it can be seen that the t statistics value for all three samples are greater than t critical to tail. Hence, the results provide strong evidence against the null hypothesis. Hence, concluding that means of these two data sets for the same sets of objects when compared pre-COVID and COVID years are statistically different for energy and number of operating hours. This paper explores the effect of lockdown due to COVID-19 on residential buildings. Due to the stay-at-home orders, the energy demands of residential buildings increased. Based on the hypothesis made, an analysis performed. Following are the key observations. The household electricity consumption increased during the lockdown. The overall AC energy consumption and operational hours increased in 2020 compared to 2019. During the daytime, AC energy consumption was more in 2020, but during the nighttime, the consumption was more in 2019. The AC energy consumption is more for set high due to high temperature range. The peak in household electricity consumption for the year 2019 was seen in the morning, but for the 2020, the peak shifted from morning to noon. Further, two direction of future work can be done. To understand the trade-offs involved between energy consumption of commercial and residential buildings, and to perform this study on a larger number of different demographics of sample and understand how the results hold or change. Thank you everyone.